live. Okay, so 1, 20, 22. So we're going to be solving trig equations in radians today, okay? And these are going to take some tricks. So an analogy of number 1 is this. Let's say you got 2y equals x. You get two variables. You can't solve for x or y. You can't get an answer. You guys agree? There's no way. So what we're going to have to do is somehow change it. But I do know this. Before we do it, what is tangent? What is tangent? What do you think I'm going to do? I'm going to divide by cosine on both sides. So if I divide by cosine on both sides, I'm going to have a 2 tangent of x equals 1. And now I can do it, right? So I completely change sine and cosine into tangent so that I have one trig expression. Divide by 2. Tangent of x equals 1/2. Let me change my calculator into radians, right? Mode into radians, enter, quit that. So I'll go tan inverse, right? Of 1/2. So I'll go tan inverse of 1/2. And it's an angle. It doesn't look like an angle, but hopefully by now you guys are realizing that 0.4 is an angle. It's probably about 25 degrees, something like that. So x1, angle 1 is about a 0.46. And then my reference angle chart says that we're going to take for x2, it's going to say take 0.46 plus pi. For some reason, I don't know where mine is, but it's all right. But if you look at remember your angle chart tells you how to get the other one, right? I'm going to add pi to that for my second angle. Plus pi, and I can answer about 3.6. How's that? So the trick, the start was to make it into tangent, right? That was the trick, okay? Okay, now number 2, you got to be careful on number 2 because if you divide by sine, you'll lose an answer. Does that make sense? If you divide by sine, you get rid of the sign, you actually lose an expression. What we do instead is we're going to factor. We're going to factor out a sign, and then we don't lose the sign. So I'm going to take the sign over to the other side. I'm going to bring them together. So I'm going to take the sign over here. Sine of x, tangent of x, minus 3, sine of x equals 0, okay? And then if I common factor out the sign, I don't lose it, right? Common factor out my sign. I'll have a sine of x times the tangent of x minus 3 equals 0. Are you with me? Now, even though there are sines and tangents, I still can do my mini equations. Does that make sense? All right, great question. Let's use x and y. It's a really good question, Lauren. Let's use x and y as a stick, okay? If I had x, y minus 3x equals 0, it's basically just taking out the x. You with me? So x in common factor out the x, right? Sine in common effect out the sign. Okay, thank you for that clarification, right? So now I can solve the two mini equations because it's this times this, so I'll do my mini equations. Sine of x equals 0 and tangent of x minus 3 equals 0, right? This is on the circle. You could use your calculator if you want to, but it's 0 and pi. Okay, a y value of 0 happens here at 0 radians and happens here at pi radians. Tangent of x equals 3. is not on the circle, so I'm going to have to do my tangent inverse of 3. Okay? Am I going too fast? Okay, so I'm going to go tan inverse of 3. And I get an angle, 1.25. So x3 is a 1.25. But there's a reference angle, the other angle that goes with it. And I lost my sheet, but my sheet, yes, Ellie?
Oh, I can wait till you finish up.
So I'm just going to go pi plus, because that's what my little chart says. So we go plus pi. And my fourth angle is about a 4.4. Okay, Ellie, question, yes.
So on the inner circle, for these answers, you couldn't get like a sine inverse of like any number higher than 1, right?
Correct.
What makes it so you can get a tangent inverse?
Great. Do you remember when we did the graphs? Okay, I got to do this quick because I'm recording, but it's worthwhile. Okay, let's do the graphs. Okay, sine. You know what the tangent graph looks like?
Okay.
So you can have any value for tangent that we refer to. Here's theta, and here's my tangent. Okay? Good question. And with sine, the highest it goes is 1, and the same thing with cosine, right? That's good question. You guys see what she asked? Yeah. I love when you guys ask these questions. Okay, turn the page. All right. All right, now, I'll give you a hint. You can't change a sine into a cosine. You can't change a cosine into a sine. You just can't do it. But you can do a sine squared. You can do a cosine squared, and you can do a cosine squared into a sine squared. So what I'm going to do is square both sides. Here's my hit trick. So I'm going to square both sides to get a sine squared and a cosine squared. Okay, I'm going to square both sides. So I'm going to have a 4 sine squared of x equals, I'm going to have to FOIL this one, but I can do that. Okay. Okay, so 4 sine squared, that's easy. But since cosine plus 1 is quantity squared, I'm just going to write it twice, and I'm going to FOIL it, okay? So cosine squared of x plus 1 cosine of x plus another one cosine of x plus 1 4 sine squared of x. Let you catch up. Boy, it's really bright. Just you're way ahead of me. I like that. 4 sine squared of x is equal to cosine squared of x plus 2 cosine of x plus 1. Okay. Now, it's really obvious which one you want to change. Since you cannot change this cosine into a sine, you can't. But you can change this into a cosine, can't you? So let's change our sine squared into a cosine squared. Of course, our identity, and I'll write it on the side. Our identity is this. We know that sine squared of theta is equal to 1 minus cosine squared of theta, right? And I'm going to use that identity there. All right, so 4 times 1 minus cosine squared of x equals cosine squared of x plus 2 cosine of x plus 1. Man, we're doing real math when it takes a whole page to get an answer. Woo! It's fun stuff, huh? Okay. So all I did is I replaced. Just substitute sine squared with an identity 1 minus cosine squared, okay? All right, let me simplify. So if I distribute, oh, we're doing good stuff now. Imagine if I showed you this at the beginning of the year, you guys would say, I'm not taking this class. But you can do it. Look at this. You guys can do this, right? Well, with my help, you can, right? I'm probably going to want to factor. So
I'll put x's down and then I'll erase it, but you know, you were to write this as 4 minus 4x, x squared equals x squared plus 2x plus 1. You know, I'm thinking factor, right? So bring over the 4x, 5x squared, I bring over 4, I bring over the 4, and I have a negative 3, right? And then factor, right? So I'm going to do the same thing with cosines. Bring it to one side. I can factor that. That's probably going to be a 5x, x, 3 and a 1. Yeah, that's what it's going to factor into. If I get to be a positive, negative, that'll work. Okay? That's where I'm going with this, except for the cosine. Okay? So erase. Let's do the same thing, but with
add a 4 cosine squared, which would make a 5 cosine squared of x. If I add the 4 plus 4 plus 4, plus 2 cosine of x, and if I bring over the 4, I subtract the 4, and I get a negative 3, right? That does factor, we just kind of saw that already. 5 cosine of x, 3 and 1, put my 3 here and my 1 here, positive, negative, because that gives me 5 and negative 3, which makes me 2. Okay, now I've got my 2 mini equations, right? So we'll have 5 cosine of x minus 3 equals 0, and cosine of x plus 1 equals 0. I'm going to add 3 divided by 5, so I've got cosine of x equals 3/5. I'm going to have to use my calculator. That is not on the unit circle. So I'm going to go cosine inverse of 3 divided by 5. And I get an answer about 0.93. That is an angle. x1, that's an angle, 0.93. Probably about 50 degrees, equivalent, close to that, about 50 degrees. Because I know 1 radian is about 57, right? 57, yeah. So to find the other x2, if I had my chart, it would say take 2 pi minus that. As my chart says, 2 pi minus that answer, and I get about a 5.36 if I round. Okay, and then this one's pretty easy. If I go cosine of x equals negative 1, that is on the unit circle. Negative 1 for cosine is there. It's the x value, which is pi. x3 is pi. How's that? Okay, and I'm going to